Well, good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by AWS and Sumo Logic. My name is Cody, and welcome back to Techstrong Learning. We've got an exciting panel ahead, but before we get things started, I have a couple of housekeeping notes I'd like to review with you. First of all, today's session is being recorded. So if you'd like to rewatch any of our session, or if you'd like to share with your team, you will be receiving an email with a link to access the recording on demand, and you'll get that shortly after we conclude our live session today. If you'd like to engage with us, there are a couple of ways to do so. The first and the easiest option is the chat tab, which you'll find on the right side of your screen. So I'm seeing lots of good mornings and hellos, but if you see that chat section, let us know from where in the world you are joining us. If you have any questions, we do want you to send those questions into the Q&A tab. And sending your questions to that Q&A section just helps us keep track, and we want to answer as many of your questions as we can today. Additionally, if you look at the handout section, you'll see there is a version of the slides available for download, so feel free to grab those. And before we close things out today, we are giving away 4 $25 Amazon gift cards, so be sure to stick around to see if you're one of our lucky winners. So our topic today is observability with OpenTelemetry. And I'm joined today by Michael Hausenblas, product lead of OpenTelemetry at AWS, Melissa Sussman, lead technical advocate at Sumo Logic, and Michael Riordan, senior product marketing manager at Sumo Logic. So to both our Michaels and Melissa, thank you so much for joining us today at Techstrong Learning. Michael Riordan, would you like to take it from here?
Sure. Thanks, Cody, for the introduction, for having us today. We're super excited to talk about observability with OpenTelemetry. So to dive in, the majority of today's conversation will be led by Melissa, our lead technical advocate at Sumo, and from Michael, the OpenTelemetry product lead at AWS. So what will we cover today? First, we'll do a very brief introduction to AWS and Sumo Logic. If you're unfamiliar with Sumo, we'll cover a bit about our company there. We'll then dive into what OpenTelemetry is and why does it matter. And then we'll dive into some architecture and design patterns around OpenTelemetry, covering the different telemetry signals, auto instrumentation, and best practices for collector management. Following that, we'll conclude with a conversation around some trends we're seeing in collection before we dive into some important resources we've put together to help educate you around OpenTelemetry. And we have a really cool Kubernetes monitoring ebook that Melissa actually put together that you can scan the QR code to access. So I highly recommend you check that out. So to start off, we'll quickly dive into a brief overview of AWS and Sumo Logic. So obviously, today, our conversation is centered around observability. And in order to begin monitoring and troubleshooting your applications, you need to have kind of a good foundation for collecting all the different telemetry that you need. And this is a slide that we've used before at Sumo Logic to kind of give you, the 10,000-foot view of unified monitoring and troubleshooting workflow and the different telemetry data that can provide you with the insights that you need to understand what is going on, all the way down to figuring out the why and how behind any sort of performance or operational issues affecting your application. And really, that large piece of the iceberg being the logs, which is from Sumo Logic's perspective, sort of our bread and butter with regard to our log analytics capabilities. So that is sort of the foundation of our conversation, and really nailing kind of your collection strategy is pivotal. And that's why OpenTelemetry is so important, as we'll explain later in this webinar. But first, a brief overview of Sumo Logic and AWS. We've had over a decade of partnership together. We obviously are a marketplace. We're a log analytics platform for both security and observability use cases. And we've really seen tremendous success serving AWS's users. We were ISV Partner of the Year a couple of years back, and we've achieved a couple of different service designations and competencies from AWS, including most recently an observability competency as part of their cloud operations program. So we've helped hundreds of companies together kind of execute their observability strategy and ensure that their applications are reliable and secure. And we have a few success stories that you can see at sumologic.com. One that I'd like to call out is Tokyo Marine, who was able to gain full visibility into their AWS stack as they moved from virtual machines to EKS. So they could reclaim time that they had been lost digging through logs for pertinent information by centralizing their log data from EKS. And with that came improved MTTR and a single pane of glass for incident management and resolution. So highly recommend checking out our case studies page for some more joint stories that we have together. And we'll follow up with some resources at the end of this conversation where you can kind of learn more both about OpenTelemetry and our partnership. So with that, I'll pass it off to Michael and Melissa to take on the majority of our conversation around OTel. Sort of what is OTel and why does it matter?
Yeah. Hey, everybody. I'm Melissa Sussman, lead technical advocate at Sumo Logic. What is OTel and why does it matter? So this was, here we are meant to have an example of what could happen if teams are collecting data without full observability into what others on the team can kind of see. So everyone's wearing blinders on their eyes. So one thinks it's a spear, another thinks it's a tree trunk, another a rope, etc. As long as they can't observe what the others can, there is poor data fidelity. So this is sort of analogous to the IT ops world, where ideally infrastructure engineers should not need to enact application changes due to sending data to various disparate backends without knowing exactly what is going on in other areas that ideally they're not siloed in. So once a disparate system becomes much larger, particularly with federated models, standardization around telemetry becomes really important. So what if you want distributed tracing data to be analyzed somewhere other than that tracing backend, or if you have data silos? What if your team wants to route logging data into a security, due to some kind of a security threat? Or what if they want to see something in a format other than a flat CLI in the logging backend? People like having histograms and charts and better visualization, and they like having machine intelligence that can statistically analyze and parse through that data. All of that is only really possible with a unified telemetry standard that is vendor agnostic. And so that's why OTel matters. Oh yeah, so this is a little bit more on the history of OTel. And these, were originally memes that were moving around. So you'll just have to use your imagination with the PDF. Here we see what was originally, there was an XKCD comic that was lightheartedly sort of poking fun at the increasing number of standards in an attempt to sort of unify what was available, only to basically end with an additional competing standard. On the left, we can see, though, that Open Census and the Open Tracing projects each sort of originated at Google. Since the projects sort of shared a common goal of data unification, they merged in May of 2019, went under CNCF governance. And that is now the basis of OpenTelemetry, which is backed by major vendors and has sort of an incubating status within the CNCF. And so now we have Tom and Jerry memes telling us they're both OTel. Let's move on. Okay, so I also wanted to give a quick sort of overview of data collection via telemetry pipelines. So on the right, you kind of have a view of sort of a generic telemetry pipeline. This is just to sort of give you an idea of where things kind of get routed. So logs, metrics, traces, where it originates, and then wherever it needs to go, which would be those backends. This also sort of intersects with the way in which routing data is expressed via monitoring. So telemetry pipelines not only filter the data, but also produce enriched metadata that's available to various backends, regarding disparate information, such as things like Kubernetes container information, region information, GUIP information, and other logging and trace data. So OTel, as the cool kids call it, is an open standard for collection that is vendor agnostic. It's essentially a format for trace data that attempts to unify, originally was to unify the receivers. It comes from unifying those projects showed before, Open Census and Open Tracing, and it captures the traces, metrics, logs, and other application telemetry data to any backend of your choice. On the right, you kind of see the general architecture, but we get into that in a lot more detail in future slides. So that'll be really exciting when Hausenblas tells us more details. This is kind of, again, more of an overview into contextualizing open source concepts that were explored in prior slides. Here we see a hodgepodge of vendor-provided collection, instrumentation, and backends. This is what data collection kind of looks like without using the OTel standard. As you can see, it's all this separate collection. Generally speaking, we can break that down into observability architecture layers, so instrumentation, collection, and backends. The first one is actually generating that data, so the logs, the spans, and the metrics input. This happens through the instrumentation layer, which is tightly coupled to the program code. It can be handled manually, automatically, or semi-automatically. With the solutions available just a few years ago, you would need to have a separate library for handling each of these signals. I think a lot of people still do that. The next one is a collector or agent. So as you want to keep a small footprint on the instrumentation library, generally, the collector comes in handy with providing all sorts of processing capabilities. So things like we saw before, things like buffering and handling connections to the back end. It also provides enrichment capability, which sort of attaches metadata about the origin of that data. So it would be, more data around the logs, metrics, traces, and the formats of said data. So that kind of helps you navigate the signals, which now include information about that source, instance ID, the Kubernetes pod, custom tags, and so on. And then the backend stores the data and provides query and visualization capabilities. That's what you're using when monitoring what's going on in real time. So such as with using real user monitoring. That's a cool, fun keyword we'll talk about later. So as you can see, there's a lot of moving parts at each layer, and there are several instrumentation libraries available through different vendors in this version. When you want to switch from one to another, you might have a problem. You might have already invested some time in writing integrations using disparate APIs with unique configuration, and this would need to be redone when switching between libraries, which is no fun. So now we're going to see on the right what things look like with OpenTelemetry collection. So that's exciting. This is it looks like a lot, but you can see that you don't have sort of these three separate, I guess, you don't have these three separate backends and these three separate agents and these three separate everything. So essentially, unified collection methodology is a unicorn right now. It might not be 100% all the way there, but we are well on our way with OTel. So one of the sort of ideas here is that you don't have to have separate libraries and agents with each of the signals going from observability 1.0 versus 2.0, 2.0 being the thing on the right. And you can kind of see the before and after clearly outlined here. You might have to squint a little if you're at your computer. So if you recall, the stuff on the left, you might have put a lot of time and energy into writing for separate libraries and all these separate agents and managing a variety of disparate signals. And that shouldn't be the case with using OpenTelemetry, where pretty much everything except the backend is going to be streamlined and provided by the initiative. And I think even with that, there are now efforts to streamline the backend as well. So there are common libraries, collectors, and such. And then the vendors like Sumo Logic can provide our own distributions of OpenTelemetry. But the idea is that there would be some commonality to where we should share the same core code so that any individual can run, I don't know, they could run Sumo Logic, they could run, Jaeger, they could run FluentBit or whatever else they might want to be using. So we also have a single agent / collector, which allows to plug in many external data sources and correlate the signals. And it includes a rich set of processors and exporters for open standards and multiple vendors. And OpenTelemetry generally encourages vendors adopt an OTLP. So, why use it? So this is kind of another summary slide in case you fell asleep in the prior slides, because some people do. Why use the OpenTelemetry standard? Why now? There's a sort of a foundation of elite performing teams in DevSecOps. So this is kind of a best practices in general these days. Highly converged telemetry eliminates data silos across IT teams, and it simplifies analysis across increasingly deep system architectures. So that's always fun. It's also observability-driven development, so observable systems design. You build a culture of continuous improvement in observability with OpenTelemetry, and you build a culture of production, feature prototyping, and testing. Lastly, OpenTelemetry is a very popular project. It's the second largest CNCF project behind Kubernetes, with probably more code commits than are listed here, because it's always growing, but over 23,000 code commits. And it's up from 7,000 per month in 2020. So it's going. All right. In this next section, Michael Hausenblas will go through OpenTelemetry signals, design patterns, and best practices.
All right. Thanks a lot for that. And let's first have a look at the telemetry signals. Melissa already alluded to that a little bit, just a more formal introduction so that we're on the same page. Logs, I suppose everyone has already dealt with, essentially these time-stamped textual signals. And the main point really is that they are meant for human consumption, right? So you're looking up a log line and trying to figure out what is going on, where are we in that program, etc. Metrics are numerical signals. They're typically aggregating certain indicators over one or a couple of services, right? So if you have a microservices architecture, you might see metrics aggregated over 5 or 10 different services. Traces also typically work across various services. So they are they're working on the principle of context distribution over these services, and by that giving you the entire end-to-end view of that request path, usually kind of serialized or visualized through this waterfall model. You can see immediately visually where something, where an execution, which service, for example, along the request path is taking most of the time, and then you can drill in. Last but not least, profiles. We'll get to that at the end of the webinar. A relatively new form of telemetry signal that is capturing for a specific service, again, the resource usage, timing. Think of how much CPU a certain function, for example, might use up. And then you are also interested in correlating all these signals. And as Melissa already hinted at earlier on, OpenTelemetry is really good at providing you the metadata needed to pivot from one of those telemetry signals to the other. For example, you might be looking at the metric dashboard in the right upper corner, and you're interested in a specific example of a trace that represents a 500 error case. And that would mean you're correlating the metrics with the traces. And from there, you might want to go to a log line or to profiles for a specific service to figure out what's going on there. Why is it taking so long? Is it something on my end? Is it in my code? Or is it some third-party call that is outside of my control, my direct control? So with that, let's have a look at where we are in OpenTelemetry Upstream, in the Upstream OpenTelemetry project, in terms of the what is available. Liz already mentioned that OpenTelemetry started out as this merger of two distributed tracing projects. And so there is no big surprise that this is the first thing that was actually already available since 2020, I believe, 2021 GA. Then we moved on to metrics, stabilized last year. And this year we're focusing on logs, logging API, which actually are two parts. The one is so-called bridge API, which you as an end user are not using directly. We as vendors, we're going to use that to bridge, for example, in Java, that might be Log4j with OpenTelemetry. There's also an event API under development, but for now, you can essentially just use the log bridge API, essentially continue to use whatever you're using, your programming language, standard library or whatever library to log, and then the log bridge API will turn that into OpenTelemetry format. So as you can see, a lot of green there, but there are still a few parts that are labeled mixed, which means there are, depending on the program language, don't forget, when we talk about OpenTelemetry, we're talking about 11 different program languages, from Java to JavaScript, Python, even Rust, and things like that are available. And not all of them have the same level of stability and the same level of activity across the board. All right, now with that, we're going to talk a little bit about auto-instrumentation. And that is really this idea of, rather than having to go into your code and change something, add some OpenTelemetry dependency and emit a span manually, that you can include, and that is depending on the program language, certain agents, for example, in the case of Java, case of Python, it's essentially based on monkey patching, that will automatically generate traces and metrics. Again, various program languages have different support in terms of how many libraries and what libraries they're supporting. And if you ask yourself, what about compiled languages such as C++ or Go or Rust, this auto-instrumentation is essentially not really a thing, but there you would use things like eBPF, for example, to generate those signals automatically. I think that one is back to Melissa for a moment.
Yeah, here's some upstream contributions that Sumo Logic has done, or at least worked with. So the ones in bold, I know we've definitely done some significant contributions to, and then the ones that are not in bold, we essentially just support, and we've continued to kind of include. But I know that there's been significant contributions to Go, JavaScript, Java, .NET, and Python auto-instrumentation SDKs. And I know we've recently added PHP auto-instrumentation upstream. And Przemek Deluvsky has a really insightful post on OpenTelemetry.io if anybody wants to read that and kind of learn more. So yeah, just had to do my little plug. Oh yeah, and then the other slide is how to contribute to OTel. So this is just, there's a frequently, issues labeled with the help wanted or good first issue to go check out. And there's also a list example. Don't be shy, leave a note in the issue asking for assignment, and then keep your PRs small if possible. Each repo has a contributing.md document, which describes this in specific detail, how to do that. And please read it before contributing. And then you also have to sign a contributor license agreement, I believe, depending on which repo you're in. So yeah.
Yeah, to the last point, this contributor license agreement or CLA, that sounds much worse than it is. It's essentially you just click 2 or 3 things and you're done, right? It's not a formal letter with the signatures of your parents. You don't need that, right? It's just essentially saying I'm fine with contributing under these CNCF mandated or CNCF hosted terms. One thing I wanted to note in terms of contribution, don't necessarily think that only code is valuable, right? So if you, for example, want to improve our docs, right? For example, I'm mostly contributing to docs, or you want to contribute to the demo, right? We have a wonderful OpenTelemetry demo that you can simply use and extend to your own needs, providing scenarios, etc. Or you want to help out with testing in various environments. So any kind of contribution really is very, very welcome. So you don't have to be a developer. Anything and everything is welcome. And it's a great way to also build up your own environment and connections, and it really looks also good on the CV, right? As a from working in an environment where we usually also hire quite a lot of people, these kind of open source contributions are really valued.
Yes.
With that, moving on to the next slide, which actually is something that is really very close to my heart. not because I contributed these docs myself, but I really believe that this shows, in a sense, the power of OpenTelemetry and the flexibility that you have with it. So if you think about how you want to use OpenTelemetry in your environment, you could just essentially say you directly instrument your application code. That might be a pod running in EKS or a task in ECS or a Lambda function or whatever, and directly use the OpenTelemetry construct in your programming language to send data to a backend. That's perfectly possible. However, it does have one drawback, and that is that anytime you want to change something, for example, you decide to send it to a backend. For example, you have a dev environment, dev test, and prod. So you want to change something, you need code changes. Or you have some sampling and changing the sampling decision. You always need to touch the code, you need to change the code. Now, a more flexible way to go about that is to use the OpenTelemetry collector. That's one part of the many parts of OpenTelemetry. We heard about SDKs, we heard about the collector itself, semantic conventions. We're going to talk about that in a moment as well. And it's essentially a binary. You can run it in a container image if you want to, if you're in a container environment. And that essentially means that you configure your SDK to send OTLP, for example, the OpenTelemetry protocol, to the collector, do some kind of pre-processing. You might be batching up stuff, filtering stuff. You might do a tail sampling in there, and then send it to a destination. And that means that if you want to change anything, right? Let's say you need to implement some GDPR that's in Europe, right? Or PIPL in China, where you say, hey, I need to filter certain PII information, right? I need to drop things that might identify people. You don't need to change anything in the code. You change the configuration of the collector, and that's a runtime configuration change. For larger deployments, if you have a lot of data to process, you typically shard the OpenTelemetry collector. So that means you have a load balancer in front of that, and pretty much the same as in agent deployment mode. You're sending OTLP from your application using the OpenTelemetry SDK into the load balancer, and then spreads out to various OpenTelemetry collectors. For example, in Kubernetes, that would be a horizontal pod autoscaler, and you would essentially have a service, and behind each of the services, there is a pod where an OpenTelemetry collector runs. And each of them then ingests into one or more backends. There is a spin to that. If you have certain decisions like tail sampling, for example, you need another layer of OpenTelemetry collectors with a load balancing exporter, so that all the spans of a trace land in the same collector to make that tail sampling decision. But in general, you can think of it, you have a load balancer, so you have essentially one endpoint that you using hard coding into your program, and then the rest is essentially flexible. And again, there is no one size fits all, right? You can pick and choose, and depending on your environment, your requirements, use a combination thereof. But be aware of that those are the three overall patterns, and under upstream collector deployment docs, you will see the pros and cons and examples of that fleshed out. Now, talking about large scale, if you have many collectors, and doesn't necessarily have to be only OpenTelemetry collectors, it could be some legacy agent, it could be other open source agents like FluentBit, then you typically want to have a more structured approach to the fleet management, so the fleet of telemetry agents. And part of OpenTelemetry is the so-called OpAmp, the Open Agent Management Protocol, which allows you to manage a fleet of those agents. Here, in that context, we obviously focus on OpenTelemetry, but again, OpAmp is agnostic. You can manage any agent with it. And the basic idea is that you have a control plane. That is something that you would typically either build yourself or provided by a vendor. And then you have each of the OTel collectors that have a certain bootstrapping mechanism. In the case of the OTel collector, it would be the OpenTelemetry extension that we're working on to get into the OpenTelemetry collector. And with that, you have control in terms of status, health, and performance. That's essentially for understanding how your fleet is doing. You can push out certain configuration. You can say, hey, and now all the collectors in this availability zone, send your logs into this backend. And there are also more advanced use cases, but in general, you want to use OpAmp for this kind of fleet management, health performance, and configuration patches. If you think back of Log4j, how painful it partially was to patch an entire fleet of agents with OpAmp, you can effectively do that at scale in a very straightforward manner. All right, handing over back to Melissa for some trends we're seeing.
All right, so trends that we're seeing. As you had mentioned, OpAmp is a trend. Sorry, my dog let one rip. Sorry, I need to open this window. Opening the door. One moment. Okay, so trends that we're seeing. Yes, as you mentioned, OpAmp. So that is exciting because that's basically more related to like, at first we just wanted to get everything onto a single standard so that the collectors could basically have common backends, and then it would be easier to manage. So now there's this whole project with OpenTelemetry to manage the collectors themselves. So that's kind of a cool trend. The other one I had talked about a little bit before was real user monitoring. So it's basically, I think real user monitoring has a lot of tie-ins with tracing. Tracing also seems to have a lot of tie-ins with the beginnings of OpenTelemetry. And as you know, everything tried to get onto a common span event format, so everything was already aligned a lot with tracing. And real user monitoring is one of the more recent trends to try to get real-time monitoring on the end users, I suppose. So there's a lot of things having to do with like looking at core web vitals and looking at why there might be page load time issues. And so that's one of the big trends. And I think Halsenblas can talk to the continuous profiling and semantic conventions.
He certainly can. So I mentioned earlier on the profiles, right? Remember, that's effectively timing data, resource usage, CPU, memory, etc., in the context of a specific service, right? And if you do that continuously, right, not just once off, if you're a gopher like myself, you probably know pprof and this once off, you're doing that continuously, like every 10 seconds or every minute. This is then called, not very surprisingly, continuous profiling. And this is something that is relatively new as a whole. And it found its way into OpenTelemetry, and we're currently in the process to write up a blog post where we explain where it came from and where we are and where we are heading with that. It started all out with essentially providers in that space coming together, approaching OpenTelemetry, saying like, hey, we should make that part. We should make profiles part and first-class citizens of OpenTelemetry, in addition to logs, metrics, and traces telemetry signals. And so an OTEP was written. OTEP stands for OpenTelemetry Enhancement Proposal. And this is the formal way of proposing a new feature, let's say, or a new class of features in OpenTelemetry. Of course, that's something that we stole from other community projects, in this case, I think directly from Kubernetes, where it's called CAP. But Java had these kind of things like for 20 plus years. I remember that when I started out in 2000 or whatever as a Java developer, there were these Java community processes already. It's essentially the same idea, right? You want something, you put it together, have a vision for something, and propose a way forward. And only recently there was a PR, a pull request, essentially bringing that to the next level, bringing it as part of the specification. This is done through protocol buffers or protobufs. This is a formal way how to represent these profiles on the wire in memory, being able to transmit it through OTLP. So you can't yet use it, continuous profiling in OpenTelemetry, but keep an eye on that. It will very likely in early 2024 be available in OpenTelemetry. Last but not least, in common trends, semantic conventions, or SEMConf. This has recently been spun out of the specification, so it's formally now separated. Many reasons, but I think the most important one is that it can evolve independently of the specification. So be aware of that if you have been using semantic conventions already, that there are some breaking changes to be expected. And maybe just because we didn't really talk too much about what these semantic conventions really are, let me give you a very short elevator pitch what they are. So usually, if you talk about metadata, for example, you want to say this metric or this span originates from a certain pod in a certain Kubernetes namespace, in a certain cluster, in a certain region, then pretty much any team and every team would come up with their own ways how to name that, right, where it originates. Same is true for, if you look at metrics, how do you call the response of a HTTP GET method, right? So do you call that HTTP _ response _ status or whatever? So those are the keys, right? If you have a key value pair metadata, this would be the keys. And then you also have values, right? So for example, the runtime might, for example, be EKS, right? And these semantic conventions essentially normatively define what are the allowed keys, and for some of them also the values across the board. So both for where signals come from, we call them resource attributes in OpenTelemetry, and the metadata attached to specific telemetry signals, and those are called signal attributes. So you have attributes for that you can attach to traces, to metrics, etc. And very recently, the Elastic Common Scheme was also merged, or the intention there to merge that into OpenTelemetry SEMConf. So you essentially have one place where how to represent that. So taking these last 2 bullet points, breaking changes to be expected if you're already using SEMConf. If not, you can ignore that. And if you have been using the ECS, there is a typo. It should not be ESC. We probably have all been using Vim too much, so that's a typo there. It's the Elastic Common Scheme that is on its way being merged into OTel SEMConf. All right, that's it from my side on the comment threads.
All right, cool. Did we have? Oh yeah, the next section's me. Important resources for OTel. So navigate Kubernetes monitoring with our free ebook. So you could use that QR code, or I also put the ebook in the handouts section, and I sent a link so that people don't have to fill out a form to see the ebook, because it's requiring a business email, and like it worked for my school email, but I know there's probably students on here where it might not work for them. So there it is, the QR code. And oh yeah, so I would say, so this kind of covers more best practices around Kubernetes monitoring in general. It's not specific to OpenTelemetry, but I did write a chapter on OpenTelemetry if you wanted to go look at that. But also just kind of covers Kubernetes from its humble open source beginnings to market dominance or ubiquity. So, and then here's some other useful links. They're a little bit more specific to OpenTelemetry, obviously. So the documentation page, GitHub repository, and our page on auto instrumentation, and it helps you quickly get started with instrumenting your application with OTel. The OpenTelemetry IO blog, which you can also contribute to, OpenTelemetry specification, and then of course the Slack community if people want to join the Slack community. this, you should be able to get all these links through the handout PDF. So please take a look and download the handout. And then, of course, there's an official GitHub for Sumo Logic supported distribution of the OpenTelemetry collector. Yeah.
Awesome.
So with that, I think we're going to move over to Q&A.
Yeah, we have.
So thank you both, Michael and Melissa, for leading that conversation. Folks, if you have any questions, feel free to place them in the Q&A panel in the chat. We'll dive right in. I guess we have a couple questions that I think we can answer today. So the first one is, why is observability crucial for organizations, particularly when operating in a cloud environment like AWS?
Right. I think the short answer is because you don't want to fly blind, right? Imagine you're in the cockpit of a plane, of a commercial airplane, and you're the pilot, and you're responsible for the life of all these people in the back. And I blindfold you and say, good luck. I probably will refuse to fly that, right? Versus, you have a host of different signals at your disposal that tell you how high you are, how fast you are, etc., etc. Now it becomes if you're trained again, if you're a layperson, probably that won't work as easily, but at least you have a chance based on these signals to make educated decisions. Should I go up, down, faster, or whatever? So you don't want to fly blind. And in that context of cloud native environments where you have many moving parts, pods that come and go, Lambda functions that come and go, etc., etc. The traditional methods of this like host-centric, I'm going to see what the CPU utilization of this EC2 instance is, or some log lines in isolation, they don't really accommodate the nature of these cloud native systems. So you don't want to fly blind, and you need to take into account how fast moving and how diverse these cloud native environments are.
Great. And then the next question we received was, can you share a use case when a gateway deployment pattern would be preferred over an agent?
I don't think that there is a preferred. It's a matter of scale. So it kind of like the gateway pattern finds you rather than you find the gateway pattern. If you're running, if you have enough workloads, right, enough pods or whatever the sources are, which means the actual amount of telemetry signals, right, the volume of logs or spans or metrics that comes out of that workload reaches a certain point, certain volume, a single OpenTelemetry collector will not be able to handle that, right? So you could say for a certain amount of time, you could vertically scale it. You give it more memory, give it more CPU, and you get away with it. At some point in time, you need to horizontally scale it. And given that the OpenTelemetry collector by and large is of a stateless nature, this is actually not such a big problem. But you do need to understand where is your cutoff point, to what extent you can get away with virtual scaling, which is obviously easier, and when do you need to horizontally scale, essentially having a bunch of those collectors behind the load balancer. Not sure if that answers your question, but that's a rule of thumb how you should go about it.
Great. And I think that's the majority of questions we've gotten.
There's a third question. I just don't know how to answer it. Does Docker at logic of AWS? So, hang on. I'll put this in the chat.
Maybe we can get some more context of participant 625 concerning
nice.
what the question really means via the chat. But we do have a new question, right? And that is, are any OTel products or services already built with AI capabilities? If not, is there any roadmap planned? I'm not aware of anything directly related to the OpenTelemetry project. And remember, as Melissa showed in the very beginning, OpenTelemetry is effectively middleware, right? It sits between the sources, your application, your workload, and backends, right? It does not in itself store or make available through query or visualize anything. So while I can imagine that you can have, in general, statistical AI, so any kind of what you currently are probably experiencing across the board, the non-symbolic AI in general, in the processors itself, right? That would typically be a processor in a pipeline that, for example, could auto-magically understand what a PII data is and apply some filtering, or would automatically detect the workload and auto-instrument something or whatever. But that would typically be outside of OpenTelemetry, not necessarily in core OTel, at least the way how I see it currently. Not sure
I've heard
if you would agree.
rumors of people trying to unify query languages using AI, because that's like another
True.
area. Yeah.
True. Yes.
So there's
yes.
some
Yes,
work that I
that's
think
true.
is being done through the OTel
Yep.
community to try to make querying easier using like natural language and that kind of thing. Is there a
Good point.
roadmap planned? I mean, I think I'd have to double check with people from the working groups to see, but
So
I think right now they're just playing around with it.
we can have a look at the official roadmap. I don't think currently that anything is there. Last time I checked. Let me see. I just put that on chat here. I am not aware of anything there.
It might not be official.
Might not be official yet. Yeah.
With the question from Docker, I also put a link in the chat for running the common OpenTelemetry demo application called Astronomy Shop while using Docker. So you can do that. You can do that. Maybe that's what the question was getting at.
We have one more question here. I am evangelizing the use of service mesh to observe and monitor Kubernetes workload without modifying the code. What am I missing from the OTel world? When I initially read that, it sounded to me a little bit like mutually exclusive, whereas really it's not, right? You see OpenTelemetry support coming through across the board in service meshes, be that Istio or others. So it's really, think of OpenTelemetry as a standard way, how to represent spans and metrics and logs, and that allows you to collect and process and ingest those telemetry signals into the backend of your choice without being locked into a specific vendor solution. So what are you missing out? A standard, being able to benefit from a standard, interoperability. But as I said, I wouldn't view that as mutually exclusive.
Yeah, I mean, so service meshes have all kinds of uses outside of data collection. There's like security use cases, I suppose. There's the zero trust network group of people who would have a lot of opinions on this. But I would say OpenTelemetry, what am I missing from the OTel world? I would say like there's things you can do with just like running queries, and there's things that you can do with like getting all of the logs, metrics, trace data in more effectively, more efficiently. OTel, I mean, a lot of people who are using the project right now, they're using like specific SDKs and such. So and it's built on top of Golang. So like for people who are using Golang and they're also using like a service mesh, you have all these like disparate systems, especially if they're into like the zero trust networking stuff. So it's really hard to unify collection and manage these highly federated models without something like OTel. And that's kind of, even though those are mutually exclusive projects, I agree, like that's kind of the whole value add of OTel.
Yeah, I can give you a concrete example from our space. So this is specifically, just shared it in the chat. This is specifically in the context of AWS, specifically for EKS, Istio, with our distribution. But in general, you can do that, apply that principle to anything else, or any other distribution or platform. And yeah, I would say, I agree. Of course, there are more than just observability use cases with service meshes. But again, in the observability world, right? If you ask yourself, how should you instrument? How should you represent the telemetry signals? Then I would say, at least going forward, definitely with OpenTelemetry.
I think we have one more.
One more, it looks like, just came through. So they say, joined late. Cloud providers in general, AWS in particular, already provides different services like X-Ray to monitor your microservices. Is cost the main reason? What are the main reasons for going with adopting OpenTelemetry?
Again, OpenTelemetry is a middleware solution, right? It deals with how do you generate, collect, route, filter, pre-process, and then ingest into backend. If you have a scenario where moving for whatever reasons, right? It might be the costs, it might be whatever, from one backend to the other. OpenTelemetry will help you and make it really easy to do that. So yeah, that's my 2 cents.
I think AWS has other cost-saving tools for all those FinOps folks. I just don't remember all of them. I think also with is cost the main reason. I don't know if the cost with using AWS services is really where you're saving money with using OTel. I think it's more just in the amount of time and effort that it takes to build versus like just use some Grafana or some other vendor that's adopted OTel. And there are ways to save money with using OTel, but it's not like you're necessarily selling something to people. So when it comes to things like using fewer agents, you don't have to do as much, you don't have to do manual instrumentation as well. That's another thing. You save a lot of time on not doing manual instrumentation. I think there was an old webinar that was done by someone that was like showing how to do manual instrumentation from Sumo Logic like ages ago. And it was a long webinar. It was long. It was like more than 4 hours long. But if you don't have to do manual instrumentation, that saves time. There's also like with collector management, if you're running a bunch of different collectors and ideally you want a small footprint, you would have fewer collectors if you can use OTel collectors. Internally, Sumo Logic was running, I think at one point when we were running production workloads, it peaked at around like 400 collectors from like one particular agent. And then we basically used our own OTel collectors and we were able to use 20. And I think the idea was that you just don't have as many disparate agents and you can run things through fewer collectors. And then there's even collector management. So those 20 could also get collector management solution over that to try to save on money. That's coming up though. That's the op-amp compliance stuff that Hausenblas was talking about. So once everyone is op-amp compliant, then you have people, there are even like third parties out there that are basically taking collector management and making it have an even smaller footprint and saving people money in that way. But those people are definitely trying to, like, in my opinion, I think you're definitely being sold to in a way that's that fits with the macroeconomic times right now. So I'm not trying to sell anyone anything, but I'm just saying all the different use cases for OTel, you might be able to save money just through the fact that you are on a smaller footprint.
Right. And if you want to dive deep, I shared on the chat as well a short paper. It's just 5 pages that I put together on return on investment driven observability that discusses that topic around, there are various kinds of costs, right? There are ingestion costs and storage costs, costs of re-instrumenting if you move from one provider to the other. But the main point really is that you need to figure out what is the actual return, right? Because at the end of the day, you might be able to more or less tell your stakeholders, your management, whoever that you want to convince what the costs are. But the question is, what do you get out of it, right? the clearer your idea is, why are you doing that? Are you trying to reduce the time it takes you to fix, detect and fix an issue in production? Do you want to increase the developer productivity? What is it that you're after? And that return, you compare with the costs and can say, by investing in this solution, we can get an increase by X%. And OpenTelemetry essentially helps you across the board because it is a standard. To me, that's the most important thing, the most important aspect of OpenTelemetry. It is a standard. Bless you.
Excuse me, sneezing.
Okay.
So, are those all the questions? There just thanks a lot from someone. Yeah, you're welcome.
Hey, sorry, I didn't realize we were concluded with questions, but Michael Reardon, thank you so much for moderating those. It really went through all those questions pretty quickly. Thank you so much.
There's one more. Would you recommend OTel over FluentD? Yes, but also, like, why are you using FluentD? It's a because you're doing Golang over C++, right? So yeah, I would recommend OTel over FluentD. There you go. It's going to be more efficient just because of the language.
Perfect. Well, Melissa, thank you for tackling that last one for us. So I would like to remind our audience that we've been recording today's session. So if you'd like to rewatch, or if you'd like to share this with the rest of your team, you will be receiving an email with a link to access the recording on demand. You can also find this living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section where it will be there waiting for you. If you look in the chat, you'll see I've posted a link to our post-webinar survey, and we'd love to hear your thoughts about today's program, so feel free to click that. Additionally, we do have 4 $25 Amazon gift cards to give away. So our winners are Dundi G, TJ H, Melanie B, and Anthony D. So congratulations to our 4 winners. I'll be contacting you shortly to get these gift cards out to you. If you don't happen to see an email from me, check your spam folder just in case it happens to be filtered out. I'd like to thank AWS and Sumo Logic for sponsoring our program today. And to our audience, thank you so much for being here with us today. We really appreciate your attendance, your participation, your questions, your chats, everything. So thank you for being here. And before I let everyone go, just one final thanks to Melissa, Michael, and Michael. Thank you so much for joining us on Techstrong Learning today. Have a great rest of your day, and you may now disconnect.
Thank you.